Hey everyone, this is Michael from Bright Musical Circuits, and this is a schematic walkthrough for the dual voltage controlled comparators with a logic outputs. So we have two comparators on this that both have the same schematic for number 1 and number 2 that just gets into different op amps through the logic outputs. So we're going to start by just looking at comparator number 1. So I'm circling that now. And there's a couple lines here that you can ignore. But so starting with our main voltage input with the in1 wire pad, that's just going to the non-inverting input of this op amp. And that 100K to ground is providing a ground reference if it's an AC coupled input. And it's also going to ground the input when there's no signal there. Our threshold voltage for this comparator is whatever voltage is going to be on pin 6. And we're getting that through these two mixing resistors that are going to the two pots. The threshold pot, that's going from plus 12 volts to minus 12 volts. So that's just a variable voltage source. And then our CV1 pot, that's just attenuating the V1, voltage 1 input wire pad by grounding that out or not. So our threshold should go from probably about minus 6.5 volts to plus 6.5 volts, since these 100Ks are kind of attenuating each other, but that's going to depend on what CV input you have as well. And then the output of this, we've got some crossing lines, but the output is going up here to this diode here. And we want our output to just be 0 to plus 5 volts. So we have this diode here that's only going to pass positive voltages. And then this 2.7K and 2.2K, that's going to attenuate our signal down to about 5 volts whenever we have a positive output from the comparator. And the 2.2K going to ground is going to provide a strong connection to ground for, so we have a low output impedance to ground whenever we are needing that for whatever we're driving. So yeah, let me undo that. And yeah, and it's the exact same thing on number 2, but these are getting sent to these 4 op amps here that can respond to the 4 logic outputs. And we are going to start with the top here. This is the both output. And this is a pretty simple one. Our threshold is 0 volts because we just have the negative input grounded. And the voltage we are comparing is tied to plus 12 volts through this resistor here. So if we ignored the inputs, this would be on all the time, and because it would just be going to 12 volts through this resistor. But it's also connecting through these 2 diodes here to our 2 comparator outputs. So when these comparator outputs are going to swing negative, either one of them going to negative 12 volts, that's going to be a low enough impedance path to negative 12 volts that the voltage on pin 5 is going to go down to negative 12, at which point pin 7 is going to also go to negative 12, and that means we have an output that is off. So because either of them is able to send it down to negative 12, this is only going to go positive when both of them are positive, and that's how we get our both on output. All of these op amps have the same output structure over here. Like we saw for the regular comparators, diode and these 2 resistors provide our gate output. And then the 10K and the LED, that provides an indicator. 10K controls the amount of current that flows through the LED. If you wanted to have it very bright, you could lower that to 1K. If you're using a super bright LED, you could increase that to 33K or 47K. And that would save you a little bit of current that your system's consuming. Moving on, this is the one only output down here. And we've got inputs from the 2 comparators outputs. Comparator 1 is going to our positive input, and comparator 2 is going to our negative input. So comparator 1, and both of these are going through diodes that are passing only positive voltages. So let's look at pin 10. This is connected to ground through this 100K, and then it's connected to input 1 through this 100K in this diode. So if we ignored input 1, we would just have 0 volts. When input 1 goes positive, we have plus 12 here, and then that's going to get attenuated by these 200Ks to plus 6 here. So we have this input is either going to be 0 or it's going to be +6. Then let's look at pin 9. Ignoring the input again, 100K to +12 volts, 10K to ground. So that's acting as a voltage divider. So that's going to be 1.2 volts if we ignore the input from input 2. Now input 2 is only going to pass positive voltages. So that means when that's active, that's going to go to 12 volts. And so by writing this out, we can kind of compare what the 4 different states are going to be for this op amp. So if number 1 is off and number 2 is off, then we're going to have 0 volts and 1.2 volts. 0 is less than 1.2, so this is not going to turn on. If both of them are on, we're going to have +6 volts and we're going to have 12 volts. 6 is still lower than 12, so it's still not going to turn on. Then if we have number 2 on and number 1 off, 0 and 12, definitely not turning on. It's only going to turn on when we have +6 volts up here from number 1 being on and 1.2 volts down here from number 2 being off. Looking down at the next one, we have the exact same setup, 100K and 100K going to the positive, and then 100K and 10K on the negative, only the inputs are swapped. So this gives us our number 2 only. It's just the exact opposite inputs from the number 1 only. But it works the exact same way. This is going between 1.2 and 12 volts. This is going from 0 to 6 volts. And then finally, we've got our neither is on input. And this works pretty much in the exact opposite way of our both being on input. If we look back at the both of our comparators were going to the non-inverting input, and our inverting input was grounded, and we used a 100K to +12 volts. But down here, both of them are going to the inverting input, the non-inverting input is grounded, and the 100K is going to -12 volts. So this means that if either of the two comparators goes high, number 2 is going to go to +12, and that's going to set the threshold higher than ground, and this will turn off. So it's only when both of them are off that we get this -12 on the threshold, and our threshold will then be lower than our input, and this will turn on. Yeah, that's how this works. Our power connectors are down here, and it's the standard thing I use for all of my modules. 10 ohm resistors on the input and 10 UFs. That creates a passive low pass filter. And then we have some extra 0.01 UF filters right next to the power pins, which helps control noise and high frequency stuff. But yeah, that is how this module works. Thanks so much for watching.